All right, let's try to wrap up our muscular system notes. Remember, we're just kind of summarizing a good bit just to shorten this unit up a little bit. So we're going to jump from various topics here about muscles, about the muscular system. The first thing I really want you to know in this part is that the muscular system, I know it works, we talked about in the first part was how it works very closely with the skeletal system. It also works very closely with the nervous system. Particularly the skeletal muscles, of course, because they are voluntary. So all of our skeletal muscles have a muscle nerve supply. Motor neurons are the part of the nervous system or the nerves that stimulate a muscle to contract. So that's how we say pick up the pencil. Our brain tells our arm to do all that, and the muscles they work in unison to pick up a pencil off the desk or to write something down. The neuromuscular junction is the space that's actually between the nerve, the motor neuron, and the muscle cell. Okay, this is actually a very small electrical charge that goes between the two, which is kind of fascinating. There's a gap here. When we talk about the nervous system, we'll get into that because it's one of my favorite things to look at. There's actually a small gap in between here, and electrical currents actually travel between the two things to stimulate that muscle. So that's kind of neat. A motor unit consists of one motor neuron and many muscle fibers. So basically the motor neuron sorry, I got interrupted making my video. Anyway, a motor unit consists of one motor neuron and many muscle fibers. So that nerve that's supplying the electrical impulse or the nervous impulse to that muscle, that's called a motor unit. There's things called neurotransmitters. Neurotransmitters are these chemical agents that are released from neurons. Talked about that electrical charge. These motor neurons or these neurotransmitters also come from there. Big names: acetylcholine. Acetylcholine is a neurotransmitter that released from a motor neuron to stimulate the muscle to contract. So it causes the muscle to shorten up or to enable movement. Okay. Acetylcholine esterase, and you can see the shortenings ACH and ACH, ASE. They're much easier than trying to spell that and say that. Acetylcholine esterase is the neurotransmitter that breaks down acetylcholine and allows the muscle to relax. It goes back to its normal state of being. So what's interesting to me is that, and hopefully to you, is that every time we move a muscle, whether it's talking like I'm doing right now, or it's typing like you're probably doing, moving around on your keyboard, these neurotransmitters, acetylcholine and acetylcholine esterase, are being released over and over again. Okay, one to make the muscle contract and move, and then one to cause the muscle to relax. So there is a lot of activity going on. This is why the human body is the greatest machine ever thought of. I mean, the things that go on a cellular and tissue level is amazing. Neurotransmitters just show that. All right, we're jumping topics. Okay, like I told you we're going to. There's 3 different types of energy systems inside the human body. These supply the body with energy during different amounts of exercise. And when we hear the term exercise, we automatically think, oh, like sports and stuff. But really, any type of physical activity. Whether it's playing basketball or running away from a bear. Okay, our body has to do physical activity. So these 3 types of systems each produce ATP. And if you took me for biology, hopefully you remember ATP. Basically, well, it stands for adenosine triphosphate. It is a energy carrying molecule. Okay, I always like to say when you hear ATP, think energy. Okay, and each system is going to supply energy or ATP for the working muscles. All right, the first 2 that we're going to talk about are both anaerobic. That means you don't need the use of oxygen to do these things. Now, oxygen does help out with them, but they're able to do it without oxygen. Okay, so think on a cellular level, not so much you breathing. The first is called the immediate energy system. That's what I like to call it. You also hear it in the video I have for you, ATP PCR system. But think about this is for immediate use, okay? And this is when we use the ATP or adenosine triphosphate or the energy molecules that are stored directly in our muscles. Our human body muscles has a lot of ATP stored directly in them. And this system uses that ATP. It's for quick burst. Think about like sprinting down the hall or running away from something, jumping over a fence, just something very quick burst. Think about like a lineman in football. They don't have to run very far, but they got to go very short, very hard, and as quick as they can. Used for about 0 to 10 seconds worth of energy. Okay, this type of energy system is used for that, and this uses the ATP stored directly in the muscles. So how convenient. The second type of energy system is the lactic acid system, or the glycolytic glycolysis or glycolytic can't say it today system. It uses glycolysis, which is a process of cellular respiration. Well, kind of. This is where our body changes glucose to energy, or ATP. All right, and this will be used for providing energy to physical activity that takes from anywhere from like 10 seconds to 3 minutes. What it does is breaks down glucose, which we get from food derivatives. It's breakdown, basically anything you eat gets broken down to simple sugars eventually in the body, and we'll learn about that with the digestive system. One being glucose. You get some energy from it, some heat from it, and also some acid. Okay, and pyruvic acid is converted to lactic acid in our muscles. That's why you get the stitch in your side, or your legs start burning, or whatever, when you have to do something that takes a little bit of energy more than just a quick sprint. So, if coach asks you to run something after practice and you start getting that pain in your side, or your legs start burning, or you got a good workout or something in your arms, maybe you're doing some work outside or something like that, and you've been picking up, moving stuff over and over again, you start feeling that burn. That's the lactic acid. And the lactic acid is a byproduct that comes from the lactic acid system. The big function of it is quickly, instead of like the first system, immediate energy, is pulling that ATP out of the muscles as quickly as it can, very efficiently. This is breaking down glucose. Instead of going through this whole big process to get energy, remember, no oxygen is required. It makes energy, but it also gives that byproduct of pyruvic acid, which turns into lactic acid, which causes muscles to ache. The third type is the aerobic energy system. Aerobic uses oxygen, also called the oxidative system. We use oxygen. This is the most efficient energy system. This is peak performance of the body. We really see it coming out with activities that last longer than 3 minutes. Think about running a mile. Okay, it's probably going to take you longer than 3 minutes unless you're a world record holder, which there's not 3 minutes either. Anyway, you can see the breakdown here for you chemistry folks. Glucose again, so our body's food derivative energy source plus oxygen. It gives us this is the reactant, or the product. Excuse me, had a moment there. Carbon dioxide's released, water's released. We get lots of good energy. See, there's 38 as opposed to 2 a minute ago, and then also heat. This is our body at peak performance, okay? And all three of these systems can be trained. The more you use them, the better you get equipped at. Think about running this mile, or this 5K even, okay? The more and more you do it, the better your body becomes, the more efficient it becomes. It uses that glucose as well as that oxygen. You don't breathe quite as hard. Your muscles don't feel aching because you're not using the lactic acid system anymore. You're using the aerobic energy system. Your muscles are very adaptable, remember, and we learned that with atrophy and hypertrophy, but it's also adaptable in how the energy system is used to make those muscles work. So anyway, training, continuous use in these different energy systems, they make them more efficient. All right, jumping topics again. Types of movement. There's several more than this. There's about 12 that we could get into. I just wanted you to be familiar with these terms, especially if you're interested in something like physical education or physical therapy, anything related to the body. You'll need to know these. Adduction is the movement of a limb towards the midline of the body. Midline, remember, is an imaginary line running straight down the middle of the body. So this would be like bringing your legs together, okay? Adduction. Abduction is the movement of a limb away from the midline, so moving them apart. Flexion is bending a joint to decrease the angle, so making it more narrow. Think about if your foot's flat on the floor and then you raise your toes up to the front part of your leg. Okay, so you lift your toes up, making that angle a little shorter. That's flexion. Okay, that's a foot flexion there, bending a joint to decrease the angle. Extension is straightening of a joint to increase the angle between two body parts. So you got your foot kind of hanging up in there, and then you lower your toes down, kind of like a stretch. Okay, you push your toes down away from your leg. Okay, so it makes that angle bigger, straightens out that joint. Rotation would be if you took your leg and you kind of rotated it around in a circle, at your hip, okay, or your shoulder. You can see that. Throwing a baseball or a softball, even a movement of the body part around its axis. It rotates around. So those are 5 types of movement that I wanted you to be aware of. Some disorders, muscular dystrophy. Muscular dystrophy is a group of genetic diseases. They're all highlighted by progressive damage and weakness of different types of muscles. Sometimes you see people with MD affecting their facial muscles or their limbs. The whole reason, it can do different body parts, and also it can get worse over time. That's why progressive comes in. It's a lack of a key protein. Okay, so their muscle tissue becomes deteriorated. You can kind of see this, diagram here. Somebody, normal, healthy, muscular stature, and then somebody with MD. Let's see. It tends to affect adults. That last part there, it tends to affect adults, but more severe forms tend to occur in early childhood. So if you do have a very severe type, you can see it in children, but most of the time we see this popping up over time as people age. Myasthenia gravis is a muscular weakening that begins in the face. So whereas we saw MD can affect the face but also affect the body, this one really starts in the face. Normally it's chronic. Again, these are terms I wanted you to be aware of. Chronic, long term, they're going to have it, and progressive, it gets worse. This is where the acetylcholine receptor sites become destroyed and they get weakened. So in other words, it's stopping in the signal between your brain to those muscles, mainly in your face. You can't control it anymore. The muscle itself is probably fine. Over time, it'll atrophy because it's not being used, but it's the problem in the neurotransmitter. So you probably all strained a muscle or pulled a muscle. Notice I highlighted it here, made it big. This is where an injury to a muscle or tendon in which the muscle fibers tear. Okay, so you get a little tear oftentimes in that muscle or around the tendon itself. We call that a pulled muscle or muscle strain. Severity of it, of course, can, sometimes it can be not very severe. You rest it for a while, you do some basic physical therapy, and you're fine and dandy, or it can lead up to, surgery. The equivalent injury to a ligament, of course, is what we call a sprain. We talked about that last unit with rolled ankle. This is a muscle strain. Not the same thing. I'm not going to get too much into that. What's a muscle cramp? Muscle cramp is when those muscles contract and they can't relax. Okay, and this is caused by a lack of oxygen and accumulation of lactic acid. So using that lactic acid system a lot can cause these cramps. Sodium and potassium are used to enable contractions. So this upset level makes the muscles kind of go haywire. They contract on their own. Real quick, 2 other disorders. One is tetanus. You might have heard this called lockjaw. It is a preventable disease, but very, very serious. It's where a neurotoxin, this is a protein that acts as a poison in the body's nervous system, gets in there. The main way we really see it is through things like rust. So you step on a rusty nail or you get cut by a piece of rusty metal, and it gets in your bloodstream. Very, very serious. So if you ever stepped on a rusty nail or something, you need to go get a tetanus shot immediately. This toxin, it can kill you. It causes your muscles to spasm up and sometimes cramp up very severely. The reason it's called that is because lockjaw, that's one of the things that can happen. Your jaw can become contracted up and cramped that you can't undo it. And the last thing we're going to talk about is the last thing that happens to us, rigor mortis. Rigor mortis is the skeletal muscles partially contracting after death. They're unable to relax, and this is where people get they're a stiff. You might have heard a dead body called a stiff. It's because they go through rigor mortis. Now, after a little short time, mainly a day or two, the muscle rigor mortis lets up. So we can see some numbers here. Feel free to read those. It's mainly used to estimate the time of death. So People in law enforcement and coroners and things like that use it often.